We've got a co-presentation by Novozymes. And I have to say that one of the fun things about what we do as a company is we are able to kind of help companies, plants, facilities. We see it from the beginning, and then we kind of nurture that ultrasound program along, and we kind of see the progress that's been made. And that's, again, that's one of the fun and exciting things that we do. And I have to say, no longer than they've had their equipment, they've been able to do some fantastic things. So we've got Chuck Jarrell, Larry Shine from Novozymes, who are going to give us a really good presentation on kind of what they've done so far with ultrasound. So, show's yours.
Well, I appreciate the opportunity to come and speak with you all today about what we've been able to do with the ultrasound, the UE equipment. We'll go into a little bit about my counterpart, Larry, and about myself, just give you a brief background on us, and just walk you through what we're doing with ultrasound. And I guess the good thing that I like to be able to come down here and show is, you talk to a lot of these people, like we've seen with Chuck Peterson's presentation, people that really been involved with this stuff, and they know a lot about what's going on. So, you have to respect them for all they're doing with it. But then again, I want you guys to be able to see that we're new at this, and this is, where we're starting our journey. So there's people all around that you can learn from, and that's how we got our start, just by going and asking and looking for the education and the knowledge. So one thing about I noticed, there's only been one presenter up here all week doing the show. But we are a true team-based atmosphere at Novozymes, and when me and Larry come down here together, we put this together as a team. We do this everything we do as a team, and we realize without each other we couldn't do this. I'm not the brains behind this program by no means, but I will tell you that Larry's got a lot of experience, and Larry's done a great job with this. So Larry, he's been in the maintenance department for about 30 years. He started in the United States Navy, so I applaud him for that. Thank you for your service, Larry. That's always a good thing. Worked in the textiles, Burlington Mills there for about 10 years. And he's been with Novozymes since 1997. He's held various roles with us at Novozymes. But the biggest thing, he's been the maintenance supervisor for about 12 years. And about a year and a half ago, I approached Larry and I said, Larry, you've been doing this for 13 years. It's time for you to get out of your box and let's go do something different. And it's a wonder they didn't fire me and Larry for about fist fighting over that. But once we convinced him to come on out of that box and let's try something different, he took over our planning and scheduling department and our PDM team at Novozymes, and man, he just skyrocketed that program. So I'm very proud of what he's been able to do with it. Me, I've been in the maintenance reliability field about 20 years. I started off in the mining industry. I'm from southern West Virginia, in case you can't tell by the accent. It's good to hear the Louisiana boy's accent, because now I ain't the only funny talking one here. I worked around the coal mines in southern West Virginia for about, I guess, 4 or 5 years until I got my engineering degree. Then I went to work for Georgia Pacific in the wood products industry, and that was a big culture shock for me, going over from digging it out of the mountain to then cutting it off the top of the mountain and doing something with it. So did that for about 13 years till the housing market went in the tank, and then I said, hey, I better find something else to do, because I don't know how many more people is going to be building houses. So I went to work for Novozymes. I started off with them as the I&E reliability engineer, just going in, just seeing what was they eating our lunch, doing Pareto analysis, just doing different things. And then I moved on up to the reliability and maintenance manager about a little over 2 years ago. I got a pretty good background in reliability-centered maintenance. I've got an associate's degree in electrical engineering technology and a bachelor's degree in electronic engineering technology. I am a member of the SMRP, and I am a CMRP, so I'm very proud of that. I mean, that was my old boss man introduced me to the CMRP and showed me what benefits it had, and that's, to be honest with you, I've met a lot of really good friends now that I have through that organization, and also, I use them all the time to help me when I encounter problems, and just, anything that I have, they're a great resource. And one of the biggest things that I learned is what we do in maintenance and reliability, it's not proprietary. I mean, we all do the same thing. So it's not trades. I mean, we can share this knowledge, and our companies don't care because there ain't nothing that we do in maintenance that's going to tell you how we make our enzymes. A pump's a pump, a tank's a tank, a motor's a motor. We're going to share this knowledge on what we do with it. So by doing that, we realize that we have to help our customers grow with us also. So we started last year doing a maintenance manager's workshop for fuel ethanol plants where we brought in a bunch of our customers to just share, do best practices. You know, this is what we do here. What do you guys do where you're at? Let's figure out how we can help each other and grow together. It was a good program we did last year. We're getting ready to do the second one this year in June, and we're looking forward to just continuing this and growing with them and just letting them know what we've learned and seeing what they're doing also. I do have some notes here, so you'll have to work with me. Novozymes is located in the plant that Larry and I are at is located in Franklinton, North Carolina. We have about 500 employees there at the plant. We do produce enzymes for industrial and food feed grade applications, brewing, baking, animal feeds. Probably the most notorious is the ethanol industry. Household care, washing powders is a big one. Our enzymes is what eats the protein stains out of your clothes. We're a global company. We have sites all around the world. We have 3 sites in Denmark. We have 2 sites in China. We have 1 site in Brazil, and we have 2 here in North America, 1 in Franklinton and 1 in Blair, Nebraska. So not a bad sized company. This is our site here in Franklinton. It's a lot like a pharmaceutical. You know, they call it biotech. I just call it a bunch of buildings with a bunch of equipment in it, whatever it takes to make us some money. But this, and if you look real close up to the top left corner, see where the pond is there? Just a little bit around the corner, that's where my tree stand is. Yeah. And every year when we make this drive, that's where we kill the most of our deer. We run them out of that trees right there. When I was watching some of these other presentations, I seen the P and F curve come up. I said, hey, I got something in common with them. I know somebody's looking. What we first had to come up with is what we need to do, or what are we trying to accomplish? You know, what are we going to do to get there? First of all, we realized that we needed a strategy to help us better predict the equipment condition. You know, we was using vibration, we was using infrared, we was using ultrasound just to find air leaks, but we still wasn't getting a return like we thought we should. So we had to figure out what can put us further back on this P to F curve. You know, of course, you know, when I first started out in the industry, we actually used vibration and ultrasound together. You know, a screwdriver in our ear down on the motor, and that was combined technology back then, I reckon. But of course, you know, we've grown and we learned that technology is our friend. So the P to F curve, you know, I was introduced to this really in depth when I was going through and studying for the CMRP. I knew pretty much about it, but I'd never seen it visualized like this. And I think the visualization of it is something that really helps. And I heard somebody talking about that earlier, about a picture's worth 1,000 words and showing them how to do that. And, you know, we can always learn from this stuff, and we continue to grow and learn. That's just like I seen one of the other presenters put up there about the design phase and the commissioning phase. You know, I'm going to take that back and I'm going to use that. I'm going to expand this P and F curve utilizing what I learned this week. So I think that was pretty good. One of the other things that I wanted to make sure that I let everybody understand is the vision and mission statement. You know, we created a vision and mission statement about 2 years ago for the maintenance department, aligned it with our corporate goals. And pretty much what that says is NZNA, which is Novozymes North America Maintenance and Reliability Department, is going to maintain our plant in a cost-effective manner, driving continuous improvement, striving to enable 100% capacity utilization. You know, and all that means is, you know, we're going to make our dollars count. We're going to continue to learn and grow. And the 100% capacity utilization, all of our technicians know that just means we don't like breakdowns. We ain't going to accept them. So, and how do we do that? We keep pushing on this curve. The PDM equipment, we compared the UE systems against another leading brand. And we chose the UE 15,000. We bought 3 of them. They proved out to be so good, we went ahead and bought 3 of them, put them in. We got 3 PDM technicians that we formed a team out of, and we got them all 3 their own piece of equipment. That's how good they like using it. Some of the biggest selling points was the software and the customer support. Adrian did a great job selling this equipment to us. He backs us up. Whatever we need, he's there for us. So, you know, I'd like to say thank you for that, Adrian. You do a great job helping us out there. One of the big things about the UE is the ability to take pictures and tie that back into our CMMS. You know, that's a great tool to be able to go out there and not only be able to find the air leak, but you know what, I can take a picture of it and I can put arrows and say, right there it is, and flag it, and the guys know what to go fix. And then the air savings calculator, that was also a big plus. And I am anxious to see, you know, the steam calculator once you get that fixed. I think that'll be a great tool. This is a very busy slide, but the only reason I wanted to bring this up here is just show you that we went through an extensive process to be able to justify this. You know, the money that we put into this equipment wasn't just chump change, so we had to go out and actually sell this to our management team. And you know, this is pretty much a formal way that we do this, but it's worth putting the time and effort in. That's, you know, that's the big thing that we want to make sure that you understand. Do your homework, be prepared to answer the questions, be able to go up and show them the value and show them what it does for you. Like Chuck was talking about earlier, I noticed that he had the, you know, the same mentality when I first saw this ultrasound and what it could do for us. It puts us, you know, way ahead of advance of the vibration and the IR by being able and find this stuff earlier. And we was joking, me and Larry was joking earlier, said we're going to go home and fire a vibration tech. We don't need him anymore. We got ultrasound, you know. But we need all 3 of them. We know we just can't get rid of the others. We need all 3. But this right here tells us way in advance when we have a problem. So now we can go in and drill down with the other equipment once we realize we have a problem. And it gives us so much more time to plan and schedule this out. And that right there, it means the world when you're trying to run these plants and save the money. The more time that you can put in front of you, the cheaper it is, and the better repair you can make, and the safer it is. One of our first major uses, I guess you call this your low-hanging fruit, maybe, whatever you want to call it. It's just where we found a big opportunity to show that, hey, we're guiding us in the right direction. This was a good decision. We have a granulation mixture, and all it does is it takes enzymes and it just mixes them up, makes them into real fine particles. And it's got some chopper motors down there that it keeps all that, the raw materials and the stuff that's blending with it, chopped up into those fine particles. Well, when we lubricated those, we lubricated them according to the manufacturer, what the manufacturer told us to do. And on the chopper bearings, it was telling us to lubricate them once a month at this quantity. Well, like I heard earlier, you know, I'm sure that our technicians put 5 to 15 in it. Whatever that is, I'm sure that they was doing that. Yeah, that's it, you know. But we were still having failures. And this right here, just a slide, it shows you a little bit about it. You know, the chopper motors are right here in the middle, and they're just attached on that big mixer. And it just, you know, this is the spec sheet directly from the manufacturer. So we was doing what they was telling us to do. Like I say, the choppers, they were failing prematurely at an average of 8 failures a year. That's a lot of cost there. And if you know, the high cost, and it was labor intensive to go in and change those out. If it failed on us, on average, we lost 4 hours of production. And it was considered a breakdown every time it failed, you know, so it shut the whole building down. So it wasn't like we had a bypass around it where we can go in and fix it. It shut us down. It was, you know, it was everybody full board, let's get this back online. And the other thing we noticed is on the time-based PMs, those weren't really, they were inadequate because sometimes we would run that plant, we'd run it 24/7, and then other times we'd run it 16 hours a day for 5 days a week. So if you greased it or lubricated it on a time-based PM, you're not getting the same amount of wear in that equipment because you don't know exactly how long it actually has run during that time. So we wanted to make sure that we took a look at that. So, you know, not only were they frequent failures, but they were random, and they were just all over the place. And generally, they'd catch you in the middle of the night when you're unexpected. And they were all mainly due to improper lubrication. You know, when they cleaned the mixtures, that had a lot to do with it. And like I say, when the failure occurred, it shut the whole tower down, shut that whole building down. About $4,000 in materials and about $500 in labor. If you wasn't spending any money on overtime, this is just, you know, basic labor wages. And then the 4 hours of lost production was approximately $60,000, about $15,000 an hour on just on that one building. So every time that we kept this from failing, it was about a $65,000 cost avoidance. So, and that's, you know, that's nothing to blink at. You know, 8 times a year, do the math. I ain't doing it. So what did we do? Well, first of all, we went in, we listened to the bearings, and we recorded a sound file what was going on with them. We began to lubricate the choppers using the ultrasound equipment. And we greased it and lubricated it until the dBs remained constant. And once we got it to where we felt that, hey, that's exactly where it needs to be, then we realized that some of those bearings took 15 shots of lubricant. Some of them took 60. And here we was greasing them 12 times a year. Most of the time, I think they told us 5 to 7 shots is what they wanted us to put in it. Well, we was way off base. Some of them we wasn't greasing near enough, and some of them we was way over greasing. So we knew right then that, hey, we got to do something different. So we created this new sound file to use as a baseline. Now we know we got it where it needs to be. Let's capture this and record this data so we have something to go by. So if something changes, we can go back and we can notice that change. So we started monitoring the choppers twice a week, looking for any kind of changes or for anything going on. And we was only having to lubricate them once a week, and it was just a very minute amount. After we got the program going, then we realized that we can go back and reevaluate it, and now we only lubricate it once every 2 weeks. So, I mean, that's a big difference. You know, it's a big difference, especially, first of all, you ain't wasting all that lubrication. You ain't wasting all your guys' time going down there checking on it, or just, you know, you can put him doing something more important. This right here is the chopper motors, and I just wanted to play you a little bit of sound file so you could hear what we was hearing. This is the bass line. And then this right here is after he lubricated it. Pretty big difference. And I intentionally made them sound files longer because I got 45 minutes, so I figured y'all like to hear that. And I got more, trust me. This right here is just what the software looks like. And one thing I like about it is if you look at your file structure over here, we use SAP, right, wrong, or indifferent. Any CMMS, as long as you use it right in my book, is fine, as long as you're using them. But you can structure it just like your CMMS structure is, so you can go back in and it's apples to apples. You don't have to try to fumble through and find this. Our technicians set this up. I went through and reviewing it a couple weeks ago, and I mean, it was just simple to go through and figure out what they had going on. This right here is probably one of my favorite slides to show the management staff. We started on these choppers having problems with them, and you can see back in 2008, close to $60,000, we were spending just in maintenance on keeping these things up, trying to keep them going. We went in and Larry and them actually did some bearing fits. They noticed that the bearings was a little bit tight in the housings and stuff, so they went in and loosened the fits up. Did some maintenance, some engineering on it the way we thought we needed to do it. And they cut that in half. I mean, they did a very good job getting it down, but we still noticed the cost was up there. And if you notice in 2010, I didn't put that year in there because we went in and upgraded all the choppers, which brought in all the mixers, which come in with new choppers. So we cut that year out. But we noticed in 2011 when we brought it back, and we started analyzing the cost again, that we really was still seeing the same amount of trouble even on a brand new mixer chopper. So, even though we put the new ones in, we still had the same old problem. So we had to figure out something different to do. And that's in 2012, that's when we started lubricating using UE. The only reason that there's a purple speck on this graph is because I just threw in $1 just to show that, so it would be purple on the bottom. We have spent virtually no money on these choppers doing repairs. I mean, a little bit of PM, but virtually no money in repairs now. And that right there is something that management stands up and looks at in a heartbeat. And they know that's exactly what they want us doing. Some of the additional accomplishments, I've heard a lot this week about looking at air leaks, lubrication with it, looking at steam leaks, but vacuum systems on evaporators, that's another place we use ours. We brought up a brand new facility out in Blair, Nebraska, and they had trouble getting their evaporators running. And they knew they had some leaks and stuff, but they couldn't find them. They couldn't hear them with their ear. They couldn't just go around and just find them readily with what technologies and tools they had available. So we actually put our PDM guy on a plane, sent him to Blair, Nebraska. One day he was out there. He found all these leaks. They went in, did the repairs, and had the evaporator up and running just in a matter of one day. And they had been struggling with it for about a week. So, it sold them, and actually they went out and bought a UE 15,000 right after that. So. This right here was a justification we did on a salt fan bearing. And, in this, when you're doing reliability work and stuff, that's one thing that I found out. It's okay to beg, steal, borrow, whatever you got to do on this information and tools people's using. We share it readily. And I found this from a guy that was using it at a pharmaceutical plant in North Carolina that I'd met at the SMRP conference in Greensboro. And he showed us how this scenario worked, because how many times have you heard him go, yeah, that's possible, but what's the likelihood of it? Of course, and I like to use the example, we had one of our technicians, he would always put it out there as worst case scenario. I saved $1 million by finding that bearing. Well, that's not always the case. We got to weigh the probability in there. What's the likelihood of that happening also? So you can see you got a minor, a moderate, and a worst case scenario, and it gives you the dollar figures. And I know it's a little blurry, but the minor case is about $1,500 benefit. The moderate is about $150,000, and then the worst case is $1.5 million. So, of course, this is only probably 5% likelihood that if this failed, this is what the result would be. And the minor case is about 90%. So you weigh that in. So what we said is if when we found this salt bearing going bad with UE, it actually projected avoided cost was about $82,000. So that gives management a little belief that we ain't just putting fluff in our numbers. We're actually using the calculations to justify it. This right here is that salt fan. Another long audio file. I'll spare you. That was before they lubricated it with it. It's a lot better. But you know what? I guarantee you some of the guys in here that's been doing this a while, they can come in and tell me, hey, I hear something, and even in the good side of it. And that's what we need to do. We need to get better at what we're doing with it. We know it's better, but is there something we're missing? We got to make sure that we all share this. This is another one that we use to find a vacuum leak. This is what we call our fluid bed and our microgranulation fluid bed. Production couldn't get it up and running. They called for maintenance support and come down here and help us figure out why we can't get a vacuum going on it. So Larry decided to send one of our PDM technicians down there, and the actual technician himself decided that, hey, maybe I can use this UE equipment on this and see what we can find. He found all kinds of leaks down there on that one that there is no way that they could have found it with their standard techniques that they were using. They went in and repaired the leaks and had the fluid bed up and running in just a matter of hours. And if you don't think them technicians take pride when they can go in and do that, man, you almost can't get their head back out the building when they go in and find that stuff. This is one of the things that I like about this with the leak detection is you can snap the picture. You know, you go in and snap a picture of that stuff and just point right to it, right where it's at. And then this is what it looks like in the software actually. And that helps a planner out, you know, because a planner typically, if you go in and put that work order in, notification in the system, planner's got to go back out there and see what it's going to take. You take a picture of it, he knows exactly what he's looking at. And if he's a good planner, he don't have to even go out there. He knows what parts it takes. It's in the CMMS, and it saves him a bunch of time. This right here is just an example of what the air leak savings calculator looks like. This is not the updated version of it, but it, you know, it tells us not only what we identified, but as we fix these leaks, it's also got a column there to tell us what we saved by repairing all those leaks. You know, like I said, we used to use the old ultrasound equipment. We'd find leaks and stuff. They was doing on like a quarterly route. Now they're doing it all the time. You know, $60,000 in air leaks is nothing to sneeze at. And he did, before I left, one of the technicians actually told me he just did another route on another 1 or 2 buildings, and he found like $30,000 worth of more leaks. So it's a constant process. You know, these leaks, you don't just repair them and they go away. They're constantly springing new ones. So by them doing this, I mean, it's a steady pattern of them finding these savings. The steam traps, that's another thing that, you know, we're highly interested in. We've got about 250 steam traps on our site. We contracted a steam trap survey out, had a gentleman come in and show us, you know, a couple years ago, tag them, identify them, and help us find, you know, the leaks that we had. About $64,000 in potential in energy savings by fixing all those. Well, with the confidence that we have with the we'll find the air leaks and lubricating the bearings and find the vacuum leaks, you know, we realize that, hey, let's keep on rolling with this. Let's do the steam traps now. And, you know, I put in here, I'm hoping to find more about this information this week on steam traps. Well, I already have. I've already got a bunch of good notes and stuff down, so I'm looking forward to taking this back and being able to apply it to the program. And, you know, one thing that we did notice is, you know, there is incentives out there from the government when you go in and do these steam trap surveys, but they only give you like a subsidy on it like every 5 years when you do these steam trap surveys. So you can hire a contractor to come in and do it, but they're only going to give you that money once every 5 years, which you already got the equipment. You can roll with it every year and be prepared to save that money all along. One of the learnings that we had, you know, we've not had all successes. So I want to make sure that, you know, there is growing pains, and I want to make sure that we let everybody know about them. We did a sound file on this one pump, on an ultrafiltration pump, and it was recorded in November last year. We had it on a quarterly PM, but the audible noises was noticed without the ultrasound equipment before the next PM was ever coming out. So we went in and did another sound file in March, and there was a large difference noticed. You know, it had changed drastically on us in that 3-month period. So we're like, wait, what's going on here? What did we do wrong? What did we miss? So what we learned from that is if we'd have put it on a monthly PM where he was going around checking it, we would have noticed a gradual increase in that sound and that noise. And we would have caught it before we had the drastic failure. So I guess the learning that I take away from that is, you know, it's better to start in and do too many inspections than it is to push it out and not do enough. You know, at least you can, once you get a feel for what's going on, you can adjust your frequencies on your PMs. But, you know, start off with a lot of them, and then you can stretch them out as you go. Next steps, where we're going to go next with this stuff, the electrical noise. you know, with the NFPA, with the ARC ratings and stuff, they change it on us constantly. And, you know, we just went through this thing about the equipment and the clothing, the protective clothing. You can no longer just layer up on your arc flash clothing. Used to, you could put on a pair of cotton, you know, whatever rating it was, throw on another pair of coveralls, add them up, and you were good to that level, whatever it added up. Well, now it's not like that. You can't do that. You have to have the clothing tested together in order to get that rating. So they're constantly changing. They're constantly making it more difficult for us to go in and do this electrical work. So we know this equipment has the capabilities to help us out. So that's another thing we come here to find out is, you know, what's other people doing with this? What can we do with it? And then we want to send our guys to ultrasound level 2. You know, just keep investing in them. We want to learn a whole lot more about the sound files and what's going on there, and be able to utilize them more on a day-to-day basis. All right. Any questions?
Any questions?
Yeah, one of my questions, you had some of the numbers on your air savings, and one of the things I try to talk people into that are doing PDMs, do you have some calculated savings on all the failures you've actually found, bearing-wise and mechanical-wise?
Well, just like on the choppers, you know, we had those calculated savings. We actually seen a failure on that one, and it was about $65,000. That's where we come up with them numbers. But yeah, we go in and we try to make sure that we document that with the CMMS. You know, when we're finding this stuff, and we go back and compare it. We've been using SAP since about 2007, so we have a lot of good data in the system to back us up on previous failures. So now when we go in and find this stuff ahead of time, we can actually go in and show those savings.
Okay, my next question is, I mean, have you ever been approached by management about your time and the efforts to do this and show those costs?
Well, you know, whenever we first started looking into this program, you know, we went in and we realized we had one PDM technician using vibration. And of course, vibration, whenever we first started using it, I mean, it showed big dividends. It paid off. You know, we knew that we was finding stuff ahead of time. So we convinced them that, you know, look, this is what you invested in one technician, and this is what you got. Imagine what we can do with the newer technologies and with a couple more technicians. And that's what we sold them on. So they know there's a lot of training, and you got to invest in the training, and you got to, you know, it's like pulling teeth sometimes to get them to give you the money for this training. But when you start showing the benefits, it keeps getting easier because they, you know, it's, and Larry loves my Stephen Covey and the circle of influence, circle of concern. You know, the more that you show them that you're using their money for the smart way, the bigger your circle of concern and influence gets. It's after lunch. I knew I wasn't going to get many.
Can you go over one more time how you convinced them to keep IR and vibration, including ultrasound?
Well, if you remember the.
I can see my notes saying this is better than that, or let's do this. Not.
Well, on the way we put it to them is the ultrasound does a very, very good job at finding this early. Okay, it might not be as good as pinpointing exactly where the problem is, but it finds it a whole lot earlier. And then you use your other technologies to back it up. And like me and Larry found that our ultrasound guy, he'll go find something, and he'll go out there and he'll ask the vibration tech, which has been doing it a lot longer, hey, can you come and help me verify this is going on? The vibration guy can't find it. He won't find it then, but when it starts gradually getting up to where he does find, where vibration can find it, then you know it's time to actually, you know, you better be taking some action. So it just buys that window, and then when it's sort of like trigger points. When you see it with vibration, then you see it with IR, you start seeing that heat temperature, you ain't got long before it fails. So it helps you, you know, just gauge it a little bit better. And once you can show them all those work in conjunction together, they generally don't have a problem with that.
Trained any of your vibration folks in ultrasound?
Yeah, actually, our goal, well, Larry, why don't you answer that for us?
Well, right now we've got
Right now, we've got one vibration analysis guy. He's a level 1, and 2 ultrasound guys. The ultrasound guys are actually training part of the time for vibration because to me that was a more difficult, longer curve on how to get there. The ultrasound, he's going out in the field and doing some greasing with them and stuff like that, but he's not a level 1 yet. So we're working that way. But after the meeting this morning, I'm not sure which way we're going to head in. I'm not sure if vibration is the way to go now or not. Ultrasound is definitely a whole lot quicker. We can do a lot more pieces of equipment with ultrasound. I guess the analyzing for the vibration analysis is kind of slow.
You know, our goal was to actually have, you know, to break the plan up into like 3 or 4 different areas. And actually, when we go back, we're going to try to justify adding another head count to our PDM team. And they're probably not going to give us money to hire somebody. So we're probably going to have to go in and show them that we can take a man off from the regular execution team, bring him over to the PDM team and help us find this stuff earlier so we can plan and schedule it. But we want to have them all of them trained up in all 3 disciplines so they can own that equipment, you know. And, you know, there's cross-functional area questions and stuff, and we can get into big debates on having cross-functional maintenance guys or whether they need to be specialized or all that. But I don't think that's really the issue. I think it's just to make sure they have the ownership of it. And when they go in and they find this stuff and they can use all 3 technologies together, man, it just gives them such a big boost, you know. And, you know, the CMRT that they're talking about, you know, we have, actually right now in Novozymes, we have about 4 guys that are CMRPs. Larry's actually going to take his sometime here later this year, so to make us 5. What we would like to do is take that CMRT test and utilize that for some of our guys like the PDM technicians that's got all this wrapped together, and that might be how they get to top pay. You know, you can go take that test and it shows that you know what you're doing, so that might help us there.
Anybody else?
I got just one last thing that I wanted to throw in there is, you know, the hardest part to any of this reliability and maintenance stuff that we're doing is sustaining this stuff. You know, we can come to these conferences, we can find the flavor of the day, we can go back, we can put it in, we can run with it for a couple months. You do good with it, and then it goes away. Keeping it flowing, keeping it, you know, so when I'm dead and gone, when Larry's dead and gone, they're still doing this stuff. That's the key. You know, like 5S, you know, most people implement 4 S's, they forget that 5th S, and they never sustain it. You know, that S is important. In 2000, Novozymes actually got the North America Maintenance Excellence Award, the NAME Award, there at the Franklinton site. By no means could we get that award today, but we're back on that journey. So hopefully, you know, when you get all this stuff in your toolbox, you figure out a way to make it stick and make it last. That's the key, if you ask me, to making sure this stuff goes on and on for forever.
Do you have any advice on that, on how do you keep the program sustainable?
Document. Documentation and data is the key to everything, you know. Constantly we get, you know, we're in the middle of an organizational change right now. We're getting a new VP. You know, you get all these new people in, so you have to resell it. It's like every 1.5 to 2 years, we got to resell it to the next manager that's coming in. But as long as you're keeping this data and you're documenting and tracking it all along, then they can come in and they can see this, you know. When they go in and they see your guys in the shops and the shops are clean and the guys are happy about what they're doing and they enjoy it, and you got the guys going in the right direction and they take pride in it, then it don't take long for them to realize, hey, they got something going on here. Let's pay attention to it.
We actually put our vibration analysis program and our ultrasound program into our SAP, so a work order is generated every month. So Chuck's there, no matter who's there, that work order is for the PDM guys. So that's one way.
Yeah.
Are you putting those images back in your SAP too?
Yeah, we're attaching them to the notifications. Yeah, I get I've been to a couple of these different conferences, and you hear people, you know, especially working with some of the smaller ethanol plants that run on a tight budget and stuff. Oh, we can't afford SAP, we can't afford Maximo, whatever. You know, it's not about what CMMS system you have. Utilize what you got. And but you know what? Excel spreadsheets, they'll do the same thing for you if you know how to use them. You know, files with pictures, email. You know, with technology's there. You might not be able to afford the Cadillac, but Volkswagen will get you there.
Okay, fantastic job where the rubber meets the road, for sure. Thank you.